Hi everyone, meet Jane. Like you, she's learning about nutrition. And like you, Jane struggles with understanding some of the more complicated concepts. So let's work together to figure them out. One of the concepts that can be difficult to understand is the Krebs cycle. This cycle sometimes goes by the names citric acid cycle or the TCA cycle. Here is an overview visual of what the Krebs cycle looks like. Let's break it down step by step. Acetyl CoA combines with a 4-carbon molecule called oxaloacetate. The CoA is released and we now have a 6-carbon molecule called citrate. Citrate is then converted into isocitrate. This happens as a result of citrate losing a molecule of water and then another molecule of water is added. Isocitrate is oxidized and releases a molecule of carbon dioxide which leaves behind a 5-carbon molecule called a-ketoglutarate. NAD+ is now reduced to NADH. A-ketoglutarate then oxidizes, reducing NAD+ to NADH, and in this process, a molecule of carbon dioxide is released. The remaining 4-carbon molecule picks up CoA and forms the unstable compound called succinyl CoA. The CoA of succinyl CoA is replaced by a phosphate group, which is then transferred to ADP to make ATP. Sometimes GDP is used instead of ADP and forms GTP. The 4-carbon molecule produced here is called succinate. Now succinate is oxidized and forms another 4-carbon molecule called fumarate. In this reaction, 2 hydrogen atoms and their electrons are transferred to FAD and produces FADH2. A molecule of water is then added to fumarate, which converts it to malate. Malate oxidizes and forms oxaloacetate, which takes us to the start of the cycle again. That's it. Now look how happy Jane is now that we've broken down the various steps of the Krebs cycle.